Hi everyone and welcome to this my video on the graphs of sine and cosine. Now again, this is for the methods course here in Australia, but bearing in mind graphs of sine and cosine are universal, I'm pretty sure you are going to find something of use if you're doing A-levels or any other course around the world. Now, learning objectives are always behind me because it's a good idea to go, right, this is what I'm planning on getting across and this is what really you need to know to smash this course. Now, my name's Darren from Maths Guru. I think I may not have said that already. These lessons are all there, the downloadable notes behind me, there are VCEE exam questions and so much more, and it's absolutely free to sign up. So head over there if you feel that these videos might, in its entirety, be useful. But let's see, understand how to sketch standard graphs of sine and cosine, know what it means by amplitude and period, really important. Know how to dilate from the x-axis, know how to translate the graphs from both the positive and negative directions, and know key values for sine and cosine graphs. Now, this is some way into this module of work, and so there's already been a lot of work done. And as I say here, we've looked at the difference between degrees and radians and why they're important, and why in methods we really deal with radians. We looked at defining what circular functions are with relation to sine and cosine for our unit circle, and we've looked at tan, and we've looked at a lot of time for that unit circle. And the unit circle, mastering that is really, really important. We should be able to find any manner of angles once we've got that reference angle. All right, so what else have we got? We're sketching graphs. Now, a lot of people turn around and say, why do we spend so much time in methods doing all of this stuff? Particularly trigonometry. When I started to teach trigonometry to my group a while ago, there was a universal groan. And it's like, oh. Now, whenever people groan, it makes me worry because you're already switching off. You're like, yeah, I don't want to do this. I don't want to do this. It's too hard. And the problem is, V can't know that you find this hard. And so, of course, what are they going to do? They're going to put lots of questions in. Now, putting that to one side, I'm going to give you an example of why sine and cosine is really, really important. And basically, I'm going to draw a bit of a sketch. And basically, it's a hill. And that hill basically leads into well, I could draw some water here, really, if I wanted to. I'd draw a shark. I could draw a little person on the top of the hill. I could draw sort of grass, land there. Long story short, there are so many applications we can use for sine and cosine graphs in a real world situation to model real world things that this is why VCEE and exam questions and SAC markers really, really like this stuff because we can model so much. There's a mountain and there's a lake, and we want to know how much volume is in the lake and how far is it between, and if this person jumps, how far has he got to swim before he, there's all sorts of things. I want to build a tunnel through here. How can I do that? I'm going to build a slide. What would the gradient of the slide need to be? There are so many things that methods can do. And so please focus on making sure that you understand all of this stuff. Now, before I get into this particular section, if you can subscribe to my YouTube channel, it's massive. So few people watch maths videos, and yet when people come across my content, they go, oh, actually, your stuff, and this was awesome, and I really understood it, but they never really spread the word. So if you can, just subscribe to my YouTube channel, put a like on the video, that would mean the absolute world to me. And it means that I'm not sitting in here at the moment going slowly mad talking to myself. All right, so here is a sine curve. Now, I've actually just drawn a small section of this, or I've used desmos.com to do it, because realistically, this graph goes on to infinity and beyond in both directions. It literally does that over and over again. Electricity is sinusoidal. Not that I'm imagining any of you will be able to look at what electricity looks like, and please don't try. All right, please don't try. But when I did my engineering degree, one of the things we had to do was look at electrical waves and all that type of stuff, and very exciting. So the most important things to know about a sine curve is this. One, it is repetitive. All right, it goes on, but it has certain key features. So at this moment in time, for a standard sine curve, so if I was to write into my graph y is equal to the sine of x, then I would automatically know that it would cross through the point 0, 0. And for the moment, looking at degrees, because many cases I quite like looking at degrees, it's what we've been used to, it will cross again there at 360. Now, it will also cross here at 180, but this will repeat around those points there. So it does 360 degrees, then it repeats for another 360 degrees, and it repeats for another 360 degrees. Now, that repetition, that time between repeats, we've called the period in mathematics, all right? And it's either the number of degrees or radians, that it takes before the sine curve repeats. So in this example, it's going to be 360 degrees. That period is really, really important because if ever we're going to sketch a sine curve, we need to know when it starts and when it finishes, right? Because we're going to be limiting the domain of a lot of these things as well. You know, if I've got a mountain and a lake, I don't want an infinite number of mountains and lakes. I've got to be able to put it on a scale and say, you know, my mountain starts here, my lake ends here, end of. Now, obviously, we also need to know how high our mountain is and the distance between the median line. Now, the great thing about a sine curve, it is symmetrical, all right? It is symmetrical from the top to the bottom. That's not probably the right word to use. Let's say it again. It is equal height from the middle to the top and the middle to the bottom. So let's call the middle line the median. And so this from the median line up is the amplitude. Now that is going to be exactly the same as the length of that line there, and we are not interested in the plus or minus. I don't care how high it is above the line and how whether it's above the line or below the line. I just need to know the physical size of that. So in this instance here, the standard period of a sine curve is 1 unit. Likewise, that is 1 unit. And again, the unit circle, sine and cosine, all of this interplays in here. Right? So again, if we